right, so let's go over the 7.1 problems for modeling situations with differential equations, aka modeling situations that involve rates of change. So the equations have to have derivatives in them if it's a rate of change. So first one, the learning rate for new skills is proportional to the difference between the maximum potential for learning that skill and the amount of the skill already learned. So let's take this piece by piece. So first of all, the learning rate, okay, so that's going to be a rate, meaning a derivative, is proportional. So that means we're dealing with k, so proportional to the difference between the maximum potential and the skill already learned. All right, so first of all, learning rate, that's going to be dl dt. That's the rate of the skill learned, and that is proportional to. So proportional to means it's k times whatever it's proportional to. So it's proportional to the difference, meaning subtraction. So the difference between the maximum potential. Okay, so difference between maximum potential and the amount of the skill already learned. So difference between maximum potential and the amount of the skill learned. So just take it apart piece by piece and kind of write the sentence as an equation. And this one is C. So C is the answer here. And that's it. So let's move on to the next one. All right, so a particle moves along a straight line. Its speed is inversely proportional to the square of the distance, s, it has traveled. So they're trying to trick us by using s as distance. It's not speed. So s is the distance, meaning the speed. Similarly to velocity, the speed is the rate of change of the distance. So its speed is going to be ds dt, which means we can automatically get rid of those because s of t would be distance, not speed. So ds dt is inversely proportional to. So inversely proportional means it's the one with the fraction. So it's going to be k over something. So it's inversely proportional to the square of the distance, meaning s squared. So that leaves us with a. And that's it for that one. All right, the rate of change of the perceived stimulus P with respect to the measured intensity. So rate of change of P with respect to S. So that whole sentence right there means it's the rate of change of P with respect to S. So this isn't changing over time. These two things are depending on each other. So the P is changing with respect to S. All right, is inversely proportional to. Okay, so inversely proportional to means K over something to the intensity of the stimulus. So intensity is S. So just read very carefully there. So it's dP ds, so it's not that, equals K over S. That leaves us with B. All right. A chemical is diluted out of a tank by pumping pure water into the tank and pumping the existing solution out. So the volume at any time is this thing right here. So the amount Z of a chemical in the tank decreases. Okay, so decreases at a rate. So that means we're dealing with dz dt, which isn't really telling us much because all of our options here are dz dt. So decreasing means it's negative, so keep that in mind. It's decreasing at a rate proportional to z. Okay, so decreasing at a rate proportional to z. And it's also inversely proportional to the volume of the solution. So the volume of the solution we underlined up here is 20 plus 2t. All right, so this is k times z, and it's also k over 20 plus 2z, and it's negative because it's decreasing. So that leaves us with C. And that's it. If you want more problems like this, feel free to look on Khan Academy. Every time you do it, I think it gives you different ones. So these are really helpful for interpreting word problems that involve differential equations, which we will be doing. And that's it.